So today we're going to cover section 5 of chapter 5. Today we're going to learn 2 more shortcuts. The shortcuts acronyms are SSS and HL. The SSS stands for side, 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 and the HL stands for hypotenuse leg. Now before we get to hypotenuse leg, we're going to have to learn what the parts of the right triangle are. However, let's go ahead and take a look at our first shortcut, which is called side, side, side. And what this one states is that if 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. This one I think might be the easiest of the shortcuts because we don't have to worry about is our angle included or is our side included. Here we're just looking to see, do all 3 sides have a match? So if they ask you to prove that these 2 triangles were congruent, what we would have to do is put the 3 side statements in our proof. So what we would do is look at the congruencies. Notice here that side AB has a single mark, and I'm going to match it with the side that has the single mark and the DEF. So my first statement could be AB is congruent to DE. Then I can go back and look for the next marking. And notice BC here has double, and so does EF. So then my next statement could be that BC is congruent to EF. And then lastly, the side with the 3 markings, AC and DF, are also congruent sides. So AC congruent to DF. So because I have shown that all 3 sides of one triangle are congruent to 3 sides of another triangle, then yes, these 2 triangles are congruent, and my reason would have been using side, side, side. Now they'll also ask you to write a congruency statement. The order of the letters will be important. So I could start here and say that ABC, I like to start out with one of the triangles being alphabetical, is congruent to DEF. And each one of the letters is in the appropriate spot. So for example, notice AB was the first 2 letters and it matched with the DE, which is what I put here. And then the last 2 letters, BC, match with the EF, which was what was here. And then the first and the last, AC and DF, which was what was listed here. So my congruency statement is in the appropriate order. So these 2 triangles are congruent. You could have also written a congruency statement as you could have said that triangle CBA is congruent, and then you have to reverse the letters on the DEF and call it FED. Remember, each one of the letters has to have its appropriate match. On the test, I will start out by saying, tell me the triangle that's congruent to ABC. I'll start out the first one, and then your triangle has to match mine. So the next one says, decide whether the congruency statement is true and explain your reasoning. So my explanation here would be to match everything. If it doesn't match appropriately, if it's not in the right order, then they're not congruent. All right, so here I'm going to go ahead and go in the order. So I'm going to first look for DF and HJ. So DF is over here with double, and then so is HJ. So these have the same congruency marks. So I can state that DF is congruent to HK. DF is congruent to HJ. Then I'm going to go for the second letter and the last letter. So the FG and the JK. So let me come and look for the congruency marks. So FG has 3, and so does JK. So those are also congruent sides. So I can make that statement, FG congruent to JK. And then let me go and look at the last one. And that's going to be the first and the last letter. So DG and HK And if you look at the picture, DG has the single mark, and so does HK. So these are congruent sides. So because all three sides are congruent in one triangle to all three sides in another triangle, the statement that they gave me, the statement is true, and what I used was side, side, side. Now, sometimes it'll be congruency marks. On the next slide, they're going to give us the length of each side. So we're comparing numbers instead of congruency marks on the next example. So for the next one, this time there's not congruency marks, but we do have the length of each side. So again, I'm going to look at the congruency statement and make sure everything matches appropriately with a matching corresponding congruent side. So I'm going to take the first two letters, AC and CA. Well, if you recognize, these are exactly the same two letters, just in a different order. And what they're referring to is this side in the middle, and it's got a length of 9 no matter how you look at it. So this one works. Then if I go and do the last two letters, CB and AD, CB has 7, and so does AD. So 7 equals 7. This one is also good. And now I have one more match to make, and that would be the first letter with the last letter. So AB and CD. And notice AB, though, has 3, and CD has 4. 3 is not equal to 4, so this is not a true congruence. So I could not match all three sides with three sides of the other triangle. So this statement is false. So for this one, again, we're going to make sure every corresponding side has a corresponding congruent match. So QP, first two letters with RS. QP is right here with 2, and so is RS. So yes, I can state that QP is congruent to RS. They both have the double congruency mark. Then I'm going to take the next two letters, the PT and the ST. PT has 3, and so does ST. So I can also state that those are congruent. And then lastly, the first letter, QT, with RT. And notice QT has the single mark, and so does RT. So those are also congruent sides. So this statement is true. And again, I used side, side, side. Say instead, the statement said QPT congruent to TRS. This would be false because once you check the matches, they would be different. So for example, QP and TR, remember QP had the double marking and then TR had the single. So because even though each triangle had the same looking markings, if they don't match in the same spot, then the statement is wrong. The triangles could be congruent, you just need to fix the statement and put it in the right order. So the order is very important on these statements. Everything has to match. So here is a real world problem, and it's talking about a structural support, and it wants you to explain why the bench with the diagonal support is stable while the one without the support could collapse. So anytime that you have two congruent triangles that are connected, it's always going to be the more stable structure. So you would need two congruent triangles, and the shared side, that diagonal, would create the support for it. This one over here, this bench could wobble from side to side because there's no support here in between. The two triangles that it created over here with this support would have been this one here and then this one down here. So it's creating two triangles on top of each other that create a more stable bench. Now let's cover the parts of the right triangle. So the parts of a right triangle, this is going to be important for us for our next shortcut, which is called hypotenuse leg. So what we're going to be looking for, number one, is that we're given a right triangle. So the first thing we need to look for is the right angle in our triangle, because without it, we're not going to be able to use this next shortcut. What we're going to be looking for is the location of the hypotenuse, and the hypotenuse is always going to be opposite to the right angle. So the hypotenuse is going to be opposite the right angle. It's also going to be the longest side of our triangle. The legs, these guys right here, are going to form the right angle. So where the two legs intersect, the angle that is formed will always be the right angle. So when we use the next shortcut, we have to identify first, do we have a right triangle? And then we have to know where the hypotenuse is located and where the legs are located. So our next shortcut, this is our third one now, is called HL. And the H stands for the word hypotenuse, and the L stands for the word leg. So hypotenuse is the H, and leg is the L. So notice this one only has two letters. However, we're still looking for three things. What we need to confirm first is that we have a right triangle. So this shortcut only works when you have a right triangle. And then once you've established that you have a right triangle, we're going to look to see if the hypotenuse and a leg of the right triangle is going to be congruent to the hypotenuse and leg of another right triangle. If they are, then we can state that the two triangles are congruent. So let me go ahead and draw two triangles here and show you where the markings could be located. So right here, I would have a right angle that would be marked. I'm going to call this one ABC, and this triangle DEF. And what could have been given to you is that the hypotenuses have congruencies and one of the leg pairs. They both don't need to be marked. If they were all marked, then we would have just been able to use side, side, side. We could have also been doing side angle side, which we learned from 5-3. So notice in this picture, we can show that we have angle B and angle E are right angles, which makes triangle ABC and triangle DEF right triangles. And then we also have AC marked with a congruency, which is congruent to DF, and this is the hypotenuse. And then we also have the leg that is marked. We also have a marking on BC, congruent to EF. And this would have been the leg. Now, you could have also been given that AB was congruent to DE. It would have been either or. You don't need both because those are the legs. And then if they ask you to write a statement, you would have said that triangle ABC is congruent to triangle DEF, And your reason would have been hypotenuse leg. Okay, this one I'm going to graph the 6 order pairs. So I'm going to first graph JKL, and it's got those 3 order pairs. Then I'm going to graph RST, and then I'm going to go ahead and look to see, are they congruent? The way that I'm going to determine if they're congruent is I need to find the lengths of all 6 sides, the 3 sides of JKL, the 3 sides of RST, and make sure that they do have congruent matches. So let me go ahead and graph JKL first. I'll do that one in red. So the order pair for J is -3, -2. The order pair for K is 0, -2. And then L is -3, -8. And it actually goes off the graph a little bit. So I'm just going to go ahead and graph it. And then I'm going to also graph RST. I'll do that one in blue. So my first point is 10, 0, and that is R. S is 10, -3. And then T is 4, 0. I can connect my points and create my 2 triangles. Now, I need to make sure that all 3 sides have a corresponding match. So whenever the side is vertical or horizontal and you've got it nicely, neatly graphed, you can just count the little squares. If not, you'll use the distance formula. So I'm just going to go ahead and count the squares for JK. And notice it's got 3 little squares, and so does RS. So I could show that JK and RS are congruent. Then I could also count the RT, which is horizontal, and RT has a length of 6, and so does JL. So now I also have a second congruent match. So now, though, to find those diagonal lengths, KL and ST, I need to do the distance formula. So let me do LK first. My order pair for L is -3, -8, and K was 0, -2. I'm going to plug it into the distance formula that we learned back in chapter 1. I'm going to subtract my x's and then square that, subtract the y's, square it, and then square root. So -3 minus 0 squared. -8 minus -2 squared, and this is all under the square root, -3 squared. This becomes -8 plus 2, flip it, all under the radical, 9 plus 36, and I get the square root of 45. I can break this down, leave it in simplest radical form, and I get 3 square root 5. That's the length of LK. Now I need to do the same thing for ST, distance formula again. So S is the order pair 10, 3, -3. T is 4, 0. And now let me plug it into the distance formula. So I'm going to do the distance formula for ST. I'm going to subtract my x's and square them. Subtract my y's and square them. And then square root it. So 10 minus 4 is 6. -3 minus 0 is -3. Square it. 36 plus 9. I get 45. And then break 45 down. 9 and 5. Same thing I just did. And you get 3 square root 5. So now ST and LK are all congruent. So now I have the 3 sides of one triangle that are congruent to 3 sides of the other triangle. So yes, these 2 triangles are congruent. They all have the same side length. So triangle JKL is congruent to triangle RST using side, side, side. Now, one thing that you could have also done with this is you could have also shown that you had right angles by calculating the slope of, say, JK and JL. If they were opposite reciprocals, then we would have known that those 2 lines are perpendicular, and we also learned that perpendicular lines are formed by a horizontal and a vertical line. And then the same thing in the blue triangle. show that RT was perpendicular to RS. And if that were the case, then we could show that we had a right angle here at angle J and at angle R. And we could have also then now used hypotenuse leg, but then also realize we could have also used side angle side. So sometimes our triangles will be able to be proven congruent using multiple different shortcuts. The next example wants us to show, do we have enough information to prove that these two triangles are congruent? And they have the letters here, F, G, H. I know it's kind of light. And then triangle H, J, K. And they want to know, is there enough information to prove them congruent? Well, the first thing that sticks out to me is I have a right angle here. So this tells me that I have two right triangles. And then I can also see that the side that is opposite to that right angle over here has the same markings. This is my hypotenuse on both of them. So they are marked as congruent. And then I also have congruency marks on each of the legs. So this picture does have enough information to show that these two triangles are congruent, and I would be using hypotenuse leg. We have one more example. It's a proof. Again, don't forget your given, and you were given quite a bit of information here. So let me go ahead and fill it all in. That WY is congruent to XZ, and that WZ is perpendicular to ZY, and that XY is also perpendicular to ZY. So those perpendicular lines are what's enabling me to add in the right angles here. And then I've also added in the congruency mark on WY and XZ. So what I've done here is I've pulled out the two triangles they're referring to. So they wanted me to show that WYZ, this one right here, is congruent to this one over here. And I've replaced them and redrawn them and put them in the same orientation. They're both sitting the same way to make it a little bit easier to see. So that was my given. So let me go ahead and put that in for the reason. So this is given. So now what I can do is, since I've already labeled it in my picture, I'm going to state that angle Z and angle Y are right angles. And the reason why I can state that is because of definition of perpendicular lines. And now, because I have right angles, my next statement could be that triangle WYZ and triangle XZY are right triangles, and this would be definition of a right triangle because it has a right angle. And now the last piece that I need to do is show these legs that are congruent. So my next statement could be that ZY is congruent to ZY, and this would be reflexive because the same thing equals the same thing. So this side down here, which is the leg, is now congruent because it's exactly the same side. Notice the purple and the gray there together. It's the same side for both triangles. So now I have enough information. I've got my hypotenuse marked, which was given to me. I've got my right angle that I figured out because I had perpendicular lines. So I have a right triangle, my hypotenuses are marked, and I just established the leg. So I can state that triangle WYZ is congruent to triangle XZY, and my reason is hypotenuse leg. And that is it for the notes on section 5.5.